Hello, I'm Essay, your AI essayist. Please note that all content, audio and video in this presentation are AI generated. As AI can sometimes produce inaccuracies, I encourage you to verify any factual information presented. With that in mind, let's begin.
The document, bearing the designation German patent number 37435, granted to Karl Benz on January 29, 1886, for Fahrzeuge mit Gasmotorenbetrieb, or vehicle with gas engine operation, represents a seminal moment in the codification of technological thought. It is a work of profound consequence, articulating with legal and mechanical precision and novel synthesis of existing principles into a machine that defines an era. An academic evaluation of this patent requires moving beyond hagiography to engage directly with the specific claims advanced within its text and diagrams. This essay will undertake such an evaluation, proceeding through a systematic analysis of the core technical arguments presented by Benz. The patent genius resides less in the invention of any single component and more in its radical proposition of a fully integrated, self-propelled vehicle conceived as a single, coherent system. We will explore the internal logic and efficacy of each major subsystem, as claimed by Benz, from the engine that served as its heart to the chassis, that formed its bones, assessing the validity and ingenuity of the solutions proposed in this foundational text of automotive engineering. Section 1. The foundational claim of systemic integration. The overarching argument of the 1886 patent is implicit yet powerful, the creation of a holistic, purpose-built automobile. The document describes a vehicle engineered from the ground up to accommodate its mechanical power source. This foundational claim of systemic integration is perhaps its most significant intellectual contribution. The patent drawings depict a delicate, almost skeletal frame constructed from steel tubing, a practice borrowed from contemporary bicycle manufacturing that offered a superior strength-to-weight ratio compared to traditional wooden carriage construction. The engine is positioned horizontally at the rear, a deliberate choice that places its significant mass, along with the heavy flywheel, directly over the driving axle. This placement contributes to a low center of gravity, enhancing stability, a critical concern for a lightweight, three-wheeled vehicle. The design subordinates all elements to the function of the new powertrain. The large, spoked wheels with solid rubber tires are likewise part of this integrated vision, designed to handle the specific vibrations and loads of mechanized travel on primitive roads. The entire architecture speaks to a comprehensive design philosophy, while the chassis is an active participant in the vehicle's dynamics, a true exoskeletal support for the mechanical organs within. Evaluation of this central claim reveals a profound conceptual leap. Benz articulated a machine where every part serves the whole, a unified entity. The success of this integration is evident in the vehicle's functional coherence, however limited its initial performance. This systemic approach established the dominant paradigm for automotive design, positing the car as a unique artifact, distinct in its engineering requirements from any horse-drawn predecessor. Section 2. The prime mover and its operational principles. The patent's second major section of claims revolves around the engine itself, the gas motor that gives the invention its name. Benz' design was a single-cylinder, four-stroke engine operating on the Otto cycle, a principle that was by then established. The specific claims, however, relate to his particular manifestation of it. The patent describes an engine with a displacement of 954 cubic centimeters, designed to operate at a relatively low speed of approximately 250 revolutions per minute. A key claim is the utility of its large, horizontally oriented flywheel. This component was essential for a single-cylinder engine, storing rotational inertia to carry the piston through the three non-power strokes of the Otto cycle. Its horizontal mounting was a clever aspect of the systemic integration, contributing to the vehicle's stability and converting the vertical piston motion into a smooth, horizontal plane of rotation. The engine featured mechanically operated poppet valves for the exhaust stroke, a reliable and robust solution. For the intake, however, Benz employed an automatic, suction-operated slide valve, a more complex and ultimately less efficient, arrangement that was a product of its time. An evaluation of the engine claims reveals a conservative yet effective piece of engineering. The power output, approximately 2/3 of 1 horsepower, was modest, yet the engine was lightweight for its era and functioned with sufficient reliability to prove the concept. Its design choices, particularly the massive flywheel and the horizontal layout, were pragmatic solutions to the challenges of creating a small, portable power plant. The engine was a carefully considered compromise between power, weight and operational stability, a testament to Benz methodical engineering. Section 3 The ignition system and electrical innovation, a critical set of claims within the patent, addresses the problem of ignition, a formidable challenge for early internal combustion engines. Ben's solution represents one of the document's most forward-looking elements. He devised and claimed a high-voltage electrical ignition system, a substantial improvement over the hazardous and inconsistent hot-tube ignition methods used by some contemporaries. The system, described in the patent, consists of 3 primary components working in concert. First, a battery provided the initial low-voltage electrical source. Second, a Ruhmkorff induction coil, a type of transformer, was used to step up this low voltage into a high-voltage charge capable of jumping a gap. Third, a proprietary spark plug was developed to introduce this spark into the combustion chamber at the precise moment required. A make-and-break contact mechanism, timed off the engine's camshaft, controlled the firing of the coil. The evaluation of this claim highlights Ben's deep understanding of electrical principles and their application in a dynamic mechanical environment. This trembler coil ignition was a true innovation for a vehicular application. It provided a reliable, timed, and intense spark that was relatively immune to the vibrations and changing conditions of a moving vehicle. It allowed for easier starting and more consistent combustion compared to the open flame alternatives. This part of the patent demonstrates a leap in sophistication, integrating the nascent science of electricity into the heart of the mechanical system. The decision to pursue a Battian coil ignition system was a masterstroke of engineering judgment, solving one of the most significant barriers to creating a practical, user-operable motor vehicle. Its essential architecture, a timed high-voltage spark, would become a universal standard in gasoline engines for nearly a century. Section 4 Fuel delivery and thermal management. The patent further details the methods for supplying the engine with its combustible mixture and for managing the intense heat of its operation. The claims in this area reveal a more primitive, albeit functional, set of solutions for fuel delivery. Benz claimed a system that can be described as a surface carburetor. This apparatus consisted of a small reservoir of gasoline into which air was drawn. The passage of air over the surface of the volatile fuel caused it to evaporate, mixing with the airstream to form a combustible vapor that was then inducted into the cylinder. The patent presents this as a workable method for fuel air mixing. An evaluation, however, shows its inherent limitations. The rate of evaporation, and thus the fuel-air ratio, was highly dependent on ambient temperature, fuel temperature, and the jostling of the vehicle, making the mixture inconsistent. It was a simple solution to a complex problem, a weak link in the overall design. The claims regarding thermal management detail a thermosiphon cooling system. A jacket surrounding the cylinder was filled with water. As the engine operated, this water would absorb heat, become less dense, and rise through a pipe to a cooling radiator. As it cooled, it would become denser and sink, flowing back to the bottom of the cylinder jacket, creating a continuous circulation without the need for a pump. The patent illustrates this as an effective cooling method. In practice, this was an open-loop system. The water would boil away and required constant replenishment, with the vehicle consuming as much water as it did fuel. This severely limited the vehicle's operational range and endurance. The claims related to these subsystems show Ben's capacity for creating working mechanisms, yet they also expose the technological frontiers of the period. Both the carburetor and the cooling system were adequate for brief demonstrations, proving the vehicle's viability, but they represented significant engineering hurdles that would require decades of subsequent refinement. Section 5. The transmission of power to the wheels. The claims pertaining to the drivetrain are a showcase of mechanical ingenuity, describing how the engine's modest power was managed and delivered to the rear wheels. The patent outlines a multi-stage transmission system beginning with a primary flat leather belt. This belt connected the engine's flywheel to a layshaft. Benz design incorporated a loose and a tight pulley on this layshaft, shifting the belt from the freely spinning loose pulley to the fixed tight pulley engaged the drive, effectively acting as a simple clutch. This was a common industrial practice brilliantly adapted to a vehicular context. From the layshaft, the patent claims a crucial component, an integrated differential gear. This sophisticated mechanism allowed the two rear wheels to rotate at different speeds while cornering, a mathematical necessity for stable turning in any vehicle with a solid driving axle. The inclusion of a differential in this first prototype is a mark of exceptional engineering foresight. The final drive from the differential to each of the rear wheels was accomplished via roller chains, another technology borrowed from the world of cycling. While the initial patent focused on a single speed, the architecture of the layshaft provided the foundation for a two-speed transmission implemented on subsequent models, which used a planetary gear set to provide a lower hill gear. An evaluation of the drivetrain claims reveals a complex and surprisingly elegant system. The belt drive clutch was simple and effective for the low power outputs involved. Though prone to slippage in wet conditions, the use of a differential was a conceptually advanced and essential element for creating a truly steerable vehicle. The entire system, from belt to chain, demonstrates Benz's ability to orchestrate a symphony of gears, pulleys, and shafts into a functional powertrain that provided clutch control, speed differentiation, and power transmission. Section 6. The chassis, wheels, and steering mechanism. The final set of significant claims in the 1886 patent concerns the vehicle's structure and its method of directional control. Benz's most visible and debated choice, the tricycle configuration, is central here. The patent explicitly claims a vehicle with a single steerable front wheel and two driven rear wheels. This decision was a brilliant act of pragmatic problem solving. By using a single wheel at the front, Benz circumvented the complex geometric challenge of creating a steering system for two front wheels and could turn at different angles to avoid scrubbing during a turn, a problem later solved by the Ackermann steering geometry. His solution was mechanically simple. A tiller was connected via a rack and pinion mechanism directly to the fork of the front wheel. This provided direct, if sensitive, directional control adequate for the vehicle's low speeds. The claim for a three-wheel layout was a compromise, but an intelligent one that allowed him to focus on perfecting the powertrain. The claims for the chassis, as mentioned earlier, centered on the lightweight tubular steel frame. The wheels themselves were also a specific claim point. They were wire-spoked, another cycling innovation, and shod with solid rubber, which offered a modicum of cushioning on the cobblestone and dirt roads of the era. Evaluating these claims shows that Benz made a series of deliberate choices to simplify the vehicle's dynamics and focus on the primary challenge of self-propulsion. The tricycle layout was an elegant sidestep of a major engineering hurdle. The tiller steering, while rudimentary by later standards, was perfectly matched to the vehicle's performance envelope. The entire chassis and steering system, while appearing delicate, was a logical and well-reasoned framework upon which to build the world's first integrated automobile. It was a solution for its time, designed to prove a principle rather than to provide ultimate performance. Conclusion: a rigorous evaluation of the claims within Karl Benz 1886 patent, Fahrzeuge mit Gasmotorenbetrieb, reveals a work of extraordinary conceptual clarity and engineering pragmatism. The document's enduring significance is rooted in its primary, systemic claim: the automobile as a cohesive, integrated machine, rather than a mere assemblage of a motor and a carriage. Our section-by-section analysis shows that while some of the individual technical solutions were brilliant and forward-looking, others were primitive and temporary. The high-voltage ignition system and the inclusion of a differential were strokes of genius that established long-standing engineering principles. In contrast, The surface carburetor and the evaporative cooling system were temporary expedients, functional enough to demonstrate the concept but fundamentally flawed for sustained use. The tricycle steering was a clever compromise, a tactical retreat on one engineering front to ensure victory on another. Therefore, the patent's greatness lies not in the perfection of its parts, but in the logical completeness of its whole. It presented a comprehensive, workable, and legally defensible blueprint for a new form of transport. Benz's methodical approach produced a machine where the engine, drivetrain, and chassis were conceived in symbiotic relation to one another. The 1886 Motorwagen patent is the founding text of automotive science because it laid down the core argument, a set of integrated claims that, in their totality, defined what an automobile was and would become.
We really appreciate you tuning into this AI-powered presentation. Our goal is to push the boundaries of AI in content creation, and your input is invaluable. If there's a particular subject you'd like to see us tackle next, or if you have suggestions on how we could fine-tune our AI's creative prompts, please don't hesitate to leave your ideas in the comments section. We're excited to bring you more unique content very soon.